So we have done enough theoretical sessions. It is time to change to something new, something better, something that will give us a practical knowledge. That is why in this session we are going to do our first practical experiment that will be on filters. So let's get to it. Now, the experiment that we will be doing today, that will be the study of all the passive filters. That means the filters that is being used in electronic circuit, the characteristics and property and working of that particular filter, we will see in this practical. The aim of the experiment will be to study the characteristics, properties and working of a high pass filter and also calculate the cutoff frequency. So now let's move directly to the practical. A filter, it is a component that filters the undesirable or unwanted part inside your desirable output. But why exactly we need filter inside electronic circuit? It is doing the same thing that always a filter does. It is filtering the unwanted outputs. Now let's take an example. When you're listening to the music, you're using equalizer to set your sound according to your ears, according to your mind, according to the sound which you like. Basically what you're doing is you are changing, you are filtering the high frequency output, you are filtering the bass output, you are filtering the treble output, you are filtering the high frequency output, you are filtering the low frequency sounds. So in that case electronic filter is being used. Also in case of a landline also uses a low pass or a high pass or any type of active filter in order to reduce the amount of noise created in that landline phone. Likewise, in electronic system there are so many types of use of filter. Currently we are doing it like in radios, radio frequencies, the FM radio that you are listening to, the landline phone, the audio, the microphone, the sound system, your guitar, everything uses filters, electronic filters. Generally, there are two types of electronic filter. One is your active filter. Another one is your passive filter. Now we already know what is the difference between an active and a passive. Active is a circuit which consists of op-amp, transistors, and passive is a circuit which consists of resistance, inductance and capacitance. Likewise, active filter is the filter which makes electronic filter with the help of a op-amp, a transistor, and passive filter is a type of filter which uses resistance, inductance and capacitance. Basically both of them are doing the same thing, but for today's experiment we will use a passive filter. The combination of resistance, inductance or inductance capacitance, we will use different type of passive filter in order to get the characteristics of a high pass. Now let's directly move to the types of passive filter we have. Generally in electronics there are four types of filters that we will see. First one, that is today we will see high pass filter. Second, in the next we will see low pass filter. Third one will be band pass, and fourth one will be band reject. This fourth one, band reject filter, is also known as notch filter. So these are the four types of passive filter that we will study. Now all these types of four passive filters can be used and can be made by the combination of different types of passive elements. Like we still know that there are three types of passive element that we have to use, that is resistance, inductance and capacitor. By combining this RLC passive elements, we can make a high pass, a low pass, or band pass or band reject. We can make any filter we want, any four filters we want, by using the combination of these three components. So a high pass filter can be made with the combination of RC filters, LC filters and RL filter. Likewise, a low pass filter can be made with these three combinations, band pass filter can be made with these three, and band reject can also be made with these three. The only problem is RL filter is not an efficient filter. Sometimes it is not efficient, it's just a combination of resistance and inductance. So basically what we have to do, So basically we never use RL combination filters, but you will find somewhere in some books there will be a RL filter written in there. But basically what two main components, two main filters that we use in case of a passive one is RC and LC. These two are basically we use. And for this experiment we will be seeing only the LC combination of. That means we will be seeing only the combination of an inductor and a capacitor combined together to perform as a high pass or as a low pass or as a band pass or a band reject. So for now we will first see the high pass filter. Now before going to the high pass filter operation and circuit, let's first understand what exactly a high pass filter will do. So what exactly is a frequency? Now as you can see in this picture, there are so many types of waves that is shown there. Now in this you can clearly see what exactly is the frequency. The less distance between the wave, the higher will be the frequency. The more distance between the waves, the lower will be the frequency. Generally, these types of frequency like voltage and current, a sinusoidal frequency will be there. Like in sound waves also consist of a high frequency or a low frequency. Basically when we hear a music inside our ear, that is the mixture. When we hear treble, when we hear bass, all those frequencies are mixed together to form a complex wave. Like this picture. In this picture you can see there are so many types of waves mixed together. So what the filter will do, the filter will take the unwanted frequency that you don't want to pass through it. Whether that will be a high frequency, whether that will be a low frequency, that we will discuss later. But that unwanted frequency should not pass to the output. Now as you can see in the diagram, a high pass filter is the combination of, you can see, a capacitor and inductor. So this is basically what it is a LC filter. It is the combination of LC filter. Now the position of capacitance and inductance will decide whether this will be a high pass filter or whether this will be a low pass filter. So what exactly is a high pass filter? The definition of high pass filter is, it is a type of filter which allows or pass the high frequency waves from it. Yeah, if we pass a high frequency wave through this particular circuit, the high frequency wave will pass from V in to V out. But when low frequency wave will be given to the circuit, the low frequency wave will not pass through this. This circuit will block the low frequency wave. That is why it is named as high pass filter. It will allow the high pass frequencies and it will reject or block the low value frequency waves. Now in this we have to study about two bands, pass band and attenuation band. Pass band, it is the bunch of frequency that will pass through the filter. Attenuation band is the bunch of frequency which will not pass through the filter. It is the band which will be rejected by the filter. In case of a high pass filter, the high frequency wave will be inside the pass band, but the low frequency will be inside the attenuation band. That means the filter will allow the high frequency wave, that is the pass band, and the low frequency wave will be rejected by the filter, that becomes an attenuation band. Now how it will decide that which frequency will be highest and which frequency will be lowest? We will set that particular limit, which is known as critical frequency, given by Fc is equal to 1 by 4 pi root over Lc. This critical frequency is sometimes also known as cutoff frequency. So the cutoff frequency value will be Fc is equal to 1 by root over 4 pi Lc. That Lc will be the value of the Lc that we have used inside the circuit. By changing the value of Lc, we can change the cutoff frequency. So now you can see so now let's calculate the value of Fc. As you can see, L values and Lc values is given here. So if I calculate the value of Fc, cutoff frequency will be 1 by 4 pi root over Lc. Now if I put the value of Lc here, the cutoff frequency that I will get will be 7587, that is around 7.5 kilohertz. So the waves from 0 to 7.5 kilohertz, the frequency wave of 0 to 7.5 kilohertz will be rejected by this particular filter, and it will allow the waves above 7.5 kilohertz. So not wasting enough time, not wasting enough theoretical time, let's move directly to the practical of how exactly the high pass filter actually performs. Now in order to perform this high pass filter experiment, we need three different things. First one is the CRO that you can see in your screen. The second one, this is a function generator, which is a type of output device which will give us the different types of sinusoidal frequency that we will give to the high pass filter to get filter. And the third one will be the bunch of filters we have. Now in this kit we have total 4 types of filters, from which we will be first going to use the high pass filter one. Then after the high pass we will be doing the band pass filter. As you can see, in the high pass filter we have 2 different types of capacitors like we discussed in theory, and we have one inductor which is having 5 millihenry input. Now this function generator is an output device which will give us the sinusoidal waveform or any different types of waveform that we want to filter by using this output cable. As you can see, it is written as output. This cable will give us the output from the function generator. You can easily detach the cable and you can easily attach the cable onto the output terminal. From that output terminal we will take 2 different types of signal from some function generator like sine wave, triangular wave, and this cable will have 2 different ends. That will be, a red one will be the positive end and black one will be the negative end. Now in this we can easily change the variables of that particular wave. As you can see, it is written as amplitude variable, frequency variable. We can easily vary the parameters of any wave using these knobs. And you can see in this we have so many types of buttons like frequency, function, attenuation. We can use these types of buttons in order to change the parameter of the wave. Now you can see, if I increase the value of amplitude variable, the amplitude on the screen, the voltage on the screen is increasing, like that 23, it is now 24.04, it is the maximum value. Now if I decrease again, the amplitude on the screen will get decreased. Ultimately we are changing the amplitude of that wave which is coming out of the frequency generator. Now if I change the frequency of that wave, you can see I am changing the frequency variable knob. The frequency on the screen is changing. It is changing from 708, now it is 708. Now if I increase the value of frequency, again the frequency value will increase to 1k. It is only going to 1k because I have changed the set to 1k. What if I want to go beyond 1k? What if the frequency we have in a function generator is, now you can see in the screen it is in the maximum value 1k. If I want to go more than 1k, we have to change the frequency setup in that button, frequency range. If I press this frequency range, then you can see in the screen the 1k will be changed to 10k, and if I press it again, it will be changed to 0.1 megahertz. So this is how we can change the set. You can change the maximum value of frequency or minimum value of frequency, just like we used to do in multimeters. So this is how we can change the frequency, amplitude and everything of a particular wave which is coming out of the function generator. Now you can see in the right side of the frequency range, it is written as sine, because the function generator now it is generating sine. If I press that function button, it will be changed to square, again it will be changed to triangle, again if I press it will be changed to DC, again if I press again it will go to sine. So it is ultimately changing the type of wave that the function generator will generate. Now by default I will set it to sine wave. Now CRO is a display device in which, like in television we have different channels and every channel displays a different types of entertainment system. Likewise in CRO we have 2 different channels to display 2 different types of waveforms. CRO is basically used to measure any physical quantities waveform. That means, suppose we take, if you want to measure voltage and current, we will, if you put that voltage and current to a CRO, the CRO will give us exactly how the voltage and current looks like. Now you can see in this CRO there are 2 different types of channel, like channel 1 and then this is channel 2. We can display 2 different types of wave in 2 different channels, like from this BNC connector or through this coaxial cable which will have 2 different ends, black end and red end. I am connecting it to another coaxial cable, another black end and red end, and that particular coaxial cable through the BNC connector will be connected to the channel 1 of the CRO. When I connect it directly to the channel 1, you can see that the direct sinusoidal waveform is coming on the channel 1 of the CRO. Now the output of the function generator is connected to the channel 1. We can change the x-axis and y-axis division by changing, you can see I am changing the channel per division, which is ultimately changing the y-axis division, and we can also change the x-axis division using time per division system. Remember that we are not changing the amplitude and frequency of the wave, we are just changing the y-axis and x-axis division on the display device. Now in this CRO we also have an option to shift the waveform on upside and downside using the Y shift, and also we can shift the waveform on right to left using the X shift. According to the need, you can shift it wherever you want using the CRO's display options that you have. Now we have seen enough of our power source and our display device. Now we will directly shift toward the high pass filter. Now as you can see, we have a high pass filter in which you can see there are two capacitors and one inductor is connected. This one is single signal input and this one is your signal output. In the signal input we will connect this function generator's output, and the signal output will be connected to the CRO. Now if we will take a small cables in order to connect it to the crocodile cable. I have connected the black cable. I have connected the black cable to the black port and the red cable on the red port of the signal input. This signal input will be going to the function generators. Now in the coaxial cable end we have two different types of end at last, which is a red end and which is a black end. Now the red end of that particular coaxial cable will go to the red end or the positive end of the high pass filter. I will directly connect it. As you can see, I will be connected it directly to the red cable, and the black cable of the coaxial cable coming out of the function generator will be directly connected to the black port of the signal input of the high pass filter. You can see I will directly connect the black port to the black crocodile cable. Hence the input of the high pass filter is connected, that is coming from the function generator, which will be a sine wave. I have already settled it to a sine wave. Now the output black cable that will be connected, and the red black cable will be connected to the red port. These two ends will be directly connected to the CRO. Now from the CRO's coaxial cable, I will be taking since we have two different ends, that is red one and black one, I will be connecting it directly to the output of the high pass filter. Now the high pass filter red one will be directly connected to the high pass filter. First we will connect the black one, and then the positive of the signal output will be connected directly to the coaxial cable of the CRO. Now we will adjust the input from the function generator. Since you can see that the amplitude is already settled to 2 volt. That means I am giving the voltage to the high pass filter. Amplitude we are having as 2. You can vary the voltage also, but according to the process we will keep it at 2 volt only. And the frequency, you can see it is a sine wave, and the frequency range we have set it to maximum to 10K, and current the frequency is 1.25. Now if I want to increase the frequency, I can increase directly from the frequency variable now. You can see I am increasing, and it is increasing and it will go up to 10K, because the maximum limit we have set it is 10K. So the maximum limit which we can give is 10K. Now if I want to decrease, we can also decrease it to 807 Hz. It is the minimum point, that is 807 Hz. Now at 807 Hz, when we are giving 807 Hz input to the high pass filter, as you can see in the CRO, there is no output coming. At 807 Hz, at low frequency supply, the high pass filter is not giving anything. Now if I increase the frequency from the frequency variable knob, if I increase the frequency above 806 Hz, little by little, slowly we will increase the frequency. We can see there is some variable frequency coming, because we are increasing the frequency, and high pass filter will allow high frequency. Now you can see there is a total sinusoidal waveform is coming, because we have increased the frequency enough. It already crossed the cutoff frequency of the high pass filter. As you can see, after the cutoff frequency, the output of the high pass filter will be shown to the CRO. Now the current frequency we are giving it from the function generator is 9.53 kilohertz. So at 9.53 kilohertz, we can see there is output coming through the high pass filter, because it's a high frequency wave, 9.53. Now again, if I want, you can see 10K also it is giving us values. On 10K it is also high frequency. Now again, if I want to decrease it, now if I again decrease it, you can see that it is again it is now showing us no frequency, because it is again on low frequency. At again 803 Hz frequency, 807, we have no output on the CRO. So now therefore we have concluded that this high pass filter will always pass the band which is above 7.5 kilohertz, and it will always reject the band which is less than 7.5 kilowatt, because this is a high pass filter. Now the use of this particular filter is basically on audio devices like in guitar amplifiers, like in radios, then your landlines. All these systems has a high pass filter so that the low frequency noise will not be there in the desirable output. But now let's take 2 minutes more extra time and we will discuss a little bit deep about the low pass filter, about the high pass filter. As you can see, there is a capacitor connected here. So the value of Xc that we have is 1 by 2 pi 1 by omega c, and we can also write that as 1 by 2 pi fc 1 by 2 pi f c 1 by 2 pi fc. Now as you can see the Xc is inversely proportional to the frequency. That means the higher frequency wave will get lower amount of capacitive resistance, and lower frequency will get a higher capacitive resistance if we connect it to a capacitor. So if you look closer here, when a high frequency wave will be given to it, suppose In is a high frequency wave which is trying to pass through this capacitor. So if this is high frequency, if it is greater than 7.5, high frequency means, as you can see, this is inversely proportional to high frequency means lower capacitive resistance. So that high frequency will easily pass through this. But suppose it is lower than the Fc, suppose the In is a lower frequency wave. In that case, if Fc is lower, if frequency is lower, it will have greater amount of capacitive resistance. So the low frequency, high frequency will pass, but the low frequency wave will be blocked by this capacitor and it will not go further. So by changing the sequence of the combination of LC, we can change it from high pass to low pass to band reject. Now in the next experiment, we will be doing the band pass filter using LC combination. If you have any doubts regarding this practical session, this is the new thing that we have tried. We haven't tried anything practical now, but we will be coming with more practical experiments in the day after. So if you have any doubt regarding this, you can download the Zaad Learn app. Again, you can contact me through it. If you like this experiment, if you want more experiment like this, then keep liking this video and subscribe to our channel. Until then, I will see you on the next experiment. Not lecture, experiment.